Hey guys, today I'm going to be talking to you about our parent function, so still continuing with section 1.2, and today we're going to specifically look at transformations on the parent functions. So transformations happen whenever we change the equation, change the equation of the parent function. And we'll see that if we look at the graphs. And so a transformation is just changing the graph from what it originally looked like. So remember, we have all those different graphs of what the parent function should look like. It's just going to change the way the graph looks. And there's several different transformations that can happen. You can have all of them happening at one time, or sometimes you may only have one or two. So the transformations include horizontal shifts, left or right. So that means our graph is going to shift from side to side from what it originally was. Vertical shifts up or down. So that means our graph is going to move up or down from where it originally was in the parent function. We can have horizontal stretches and shrinks, or vertical stretches and shrinks. Excuse me. We can have reflections across the x-axis and reflections across the y-axis. So those reflections, when we reflect, are going to look like a mirror image on the other side of either the x-axis or the y-axis. And then the stretches and shrinks are going to look like our graph is either getting squished or pulled apart. That's the really technical term, squished or pulled apart, for stretches and shrinks. Alright, so we've got some examples that we're going to look at. We want to know what transformations have been applied to the functions based on their graph. So right here we have a quadratic function. It's that U-shaped curve. And then over here we have a similarly shaped curve, but now it's flipped upside down. So when you see something that's flipped upside down or flipped on its side, that's telling you it's going to be a reflection. And since it's upside down, if you look, and I'm going to actually draw this over here. So we started off with a graph that looked kind of like this. All right, that was our quadratic graph. Now I want you to imagine, and it may be hard to see, but imagine you took this graph and you turned it over the x-axis. So imagine taking this graph and we're just going to flip it over the x-axis. So any point that we have that's above the x-axis, like here, is going to now come down below the x-axis. Same thing, this point that's above the x-axis is going to flip over and come down below the x-axis. And then this point that was on the x-axis, if it flips over, doesn't move, so it stays in the same spot. So that's how we get that upside down curve. And notice that bottom curve is the same as what we have over here on the left of the screen on our graph. So what we did was we took all of our points and we flipped them over the x-axis, and that got us our new graph. So because of that, we're going to say that for this first graph we have a reflection over the x-axis. Alright, so that would be a reflection over the x-axis. That's what that would look like. Alright, let's look at another example. So next we got this graph, and it's kind of hard to see on my screen. If you open your notes, it might be a little bit bigger there. But we want to know what transformations have been applied based on the graph. So I'm going to draw it over here so it's a little bit bigger. Maybe a little bit bigger. Alright, so we had a curve that looked like this, roughly. I'm not sketching it out exactly. And then in our new curve, I'm going to actually do some counting. Let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So in our new curve, and I'm drawing it over here on a different graph, we now have this point that was in the middle. If I look at this graph now it's moved over. It's moved over 1, 2, 3 over. So 1, 2, 3 over. And then it's moved 1, 2 up. So that point where the graph kind of switches from, it almost looks like it switches direction. It doesn't exactly, but being curved kind of down to being curved kind of up, almost like an S shape, like being in the middle of an S. So where it bends right in the middle, that's the point that I looked at to see where it moved so that I could redraw the graph. And then other than that, I wasn't being very precise there. Obviously, as you can tell when you compare my graph to the actual graph. But what we're going to do to try and figure out how this is transformed is we're going to pick a point of reference, one point of reference, and we're going to compare how that point moved from the first graph to over on the second graph. And with this function, which is a cubic function, or x cubed, it's easiest if you pick a point in the middle. You always want to pick a point that's on a tick mark somewhere, or on a whole number value. You don't want to pick something that might be a fraction or a decimal, because that would be hard to interpret in the new graph. So the point, if it goes through the origin, that's a really easy one to pick because it starts at 0, 0. So this point over here is the same as this point on the new graph. So I want to see how that moved. So if I look from the origin, I moved 1, 2, 3 to the right. So I'm going to write that, right 3. And then it moved up 1, 2 up. And I know my graph's not the best, but you can kind of see it over here. It moved from the origin up 1, 2 to meet right here. So it went up 2. So when we talk about the official name for that transformation, this would be a horizontal shift to the right. So I'm just going to write H shift because I don't want to write horizontal, but it'd be a horizontal shift right by 3. And when we talk about horizontal shifts, we want to tell how much it's moving because it's moving a specific number of points to the left or to the right. Now it also moved up. Up changes things vertically. So this would be a vertical shift. I'm just going to write V shift. You can spell out vertical if you want to. Vertical shift up by 2. So we tell what direction it moved, and then we tell how many it moved. So since it went up 2, we write vertical shift up 2. All right. So that was trying to figure out the transformation by looking at the graph. And all right, that's all that's in the notes, but I do want to show you a few more examples. Excuse me. A few more examples. You can do them on your own paper and add them into your notes if you want to, but you don't have to. But what I want us to do is to transform the graphs ourselves. So I want you to be able to move the graph right 2 or up 4 or reflect it over the y-axis. So we're going to practice that. So if I tell you I want you to start with the function f of x equals absolute value of x. That's our parent function. We're going to transform it. And when we transform it, I want us to move it left 3. And then I want to reflect over the y-axis. All right, that's what I want us to do. So the first step you're going to do when trying to graph a transformed function is I always start by drawing the original graph. I want the graph of just f of x equals the absolute value of x. So if you know your parent functions really well, you could graph this by, just straight up in your head. You may not know them really well, so you can always go back and look at the assignment you did over the parent functions where you matched all of the graphs and their equations and all of that. Or you can always look at our virtual word wall, which is in Google Classroom. But the graph of f of x equals the absolute value of x. If I can draw my little tick marks here on my graph. It goes through the origin, and that's the lowest point on the original graph. So it goes through here, and then it makes a V shape, and the V shape goes up 1 over 1 every time as we move to the right, up 1 over 1. So we end up with the points 1, 1, 2, 2, 3, 3, and 4, 4, and 5, 5. And so that's one direction for our graph. In the other direction, it goes up 1, left 1 instead of right. Up 1 over 1 to the right, it's going to go up 1 over 1 to the left. And so when we do that, we get negative 1, 1, negative 2, 2, negative 3, 3, negative 4, 4. And then if we kept going, negative 5, 5, and so on. So that's the graph of the absolute value function. And when we're drawing graphs, and I didn't do a good job of that up here, but when we're drawing graphs, we want to label the y-axis and the x-axis, because if I'm looking at a graph you've drawn, like, sure, I'm pretty sure that this is what you mean, but like you could have turned it this way, and if you don't label it, for all I know, this could be your graph instead. So just make sure you label your x and your y-axis as you're drawing graphs. So what we want to do is perform our transformations. So to start off with the transformations, I am going to do all of them on the same grid and then draw my final copy off to the side. So first thing we're going to do is move left 3. And when I move left 3, I always like to pick a point on my graph and move that point to the left 3, rather than trying to deal with figuring out how to shift the entire graph. So again, the origin is always an easy point to move, so I'm going to move the origin, excuse me, I'm going to move the origin left 3. So 1, 2, 3 to the left. So now this point right here is going to be the new lowest point on our graph. And then you may be able to see how the rest of the graph would move with it, but if not, you can move another point. So if I move this point right here, 3 to the left, I go 1, 2, 3 to the left. All right, and so that's another point. And I could do the same thing with this point right here, and I know it's getting kind of crowded trying to see it all. If I move this point 3 to the left, I would go 1, 2, 3 to the left. So these 3 points over here now give me enough that I can kind of sketch out that V shape. So here in purple, I don't know if you can tell that it's purple on your screen, but here in the purple, we would get the left 3 portion of our transformation. All right, so that's the first part. We did a horizontal transformation by shifting left 3. Next, we're going to go and reflect over the y-axis. So when we reflect over the y-axis, these points on our graph, now that we've moved it left 3, these points are going to move to the opposite side of the y-axis. So this point over here is 1, 2, 3 to the left. It's going to now move to the other side and go 3 to the right. So move it all the way to the other side to positive 3. So that's our new lowest point. And you really can't tell much difference between the colors, I'm sorry. Next, this point right here is 1, 2 to the left. And when we reflect it over the y-axis, it's going to go to the opposite side and be the same distance. So it's going to be 2 to the right. So starting at the origin, it would be 2 to the right at the same height. And then this point is 4 to the left, this point right here. So on the other side, it's going to be 4 to the right when we reflect it. So it moves over here. All right, and then we can sketch out that V shape, maybe, if my pens will work with me. So now I'm going to go and I'm going to actually redraw this because I know it got kind of crowded as I was trying to draw it. So when we do our transform function, I'm just putting some random tick marks on there to give me some reference. Label your y and your x-axis. All right, now graphing my transform function. This point here was at 1, 2, 3 over and 0 up. So I'm going to come 1, 2, 3 over. So the lowest point is at 3, 0. Then I had a point to the left of that and 1 up. So I'm going to go 1 to the left and 1 up. And then we had a point to the right and 1 up. So we're going to go to the right and 1 up. All right, so that's our 3 reference points. You don't always have to have 3 if you can figure it out just from 1 point. The more points that you do the transformations with, the more exact your final graph is going to be. But here we go. This is going to be our transformed version of f of x equals the absolute value of x. So this is what would happen when we change it, moving it left 3 and reflecting it over the y-axis. Tomorrow we'll look at what that actually means in the equation, because right now I haven't given you how to get this from an equation. I've just told you moving left and right and up and down and all of that. All right, let's look at another one. There we go. I'm trying to find clean space on my paper. All right, say I give you the function, let's do f of x equals x squared. All right, so the original graph of f of x equals x squared, as I add my tick marks, and label my y-axis and my x-axis. Okay, the original graph of x squared comes down through the origin. It goes through the point 1, 1 and negative 1, 1. It goes through the point 2, 4 and negative 2, 4. It goes through other points as well that I didn't draw enough tick marks for. But if you don't remember this, you can again go back and look at the assignment you did over the parent functions, or go look at our virtual word wall. So a quadratic function, or the x squared function, is always shaped like the letter U. So that would be f of x equals x squared. Now for our transformations, we are going to move it up 4. Yeah, we're going to move up 4, and then we're going to reflect over the y-axis. And let's stop there. I'm not going to give you too many all at once. That would be a lot. So we're going to move up 4 and then reflect over the y-axis. Alright, so when we move up 4, if we start with our point here in the middle, we're going to move this point up 4 spots. So 1, 2, 3, 4. That puts us, let me get a different color. That would be too hard to see. So that puts us right here. Alright, so that we moved this point, we need to move the other points. So I do need to make my graph a little bit taller because it's not tall enough to see where the other points would be. There we go. That's a bit taller. Alright, so if we move this point right here up 4, we go up 1, 2, 3, 4. So the point would be right here. And if we move this point up 4, we would go 1, 2, 3, 4, and it would be right here. And then if you wanted to, you could move these points up as well, but at this point, you know it's going to be a U-shaped curve, so you can just shape it out like the letter U. Okay? So that gives us our up 4 part. Alright, and then next we need to reflect over the y-axis. So when we reflect over the y-axis, our points over here are going to move to the opposite side of the y-axis. So, for example, this point right here is 1 to the right. So when we reflect it, it's going to move 1 to the left. Well, 1 to the left is right here on top of this point. So I'm going to put an X. I don't even know if you can see that. I'm going to put an X to show that that's where the new point is. All right, now this point that was on the other side was 1 to the left. So when we transform this point, it's going to move 1 to the right on the other side. So I'm going to put an X again because it landed on top of a point that we already had in our first graph before we did the reflection. And then this point, since it's already on the y-axis, if we reflect it, it's not going to move. So it's going to stay in the same spot. So notice my 3 points are all still on the same line that my original graph was on. So when we reflect over the y-axis, the graph didn't change. It's because that graph right there is symmetric over the y-axis. If you think about when you were in elementary school, you probably cut out a heart, so you folded your paper in half and then cut out half of the heart, so when you unfolded it, it was perfectly even. Or if you think about a butterfly, when a butterfly flaps its wings, they close perfectly on each side of each other. You don't have like one hanging off the side or something like that. That would be symmetric. When it folds over that line, the sides would perfectly match up. So since this graph was symmetric over the y-axis, when we reflect it, we get the exact same thing. If we're trying to basically spin this graph around the y-axis, it's going to be the exact same on the other side because it was symmetric. So our final graph, if I come over here and draw it, you always have to wait for me to put the tally marks on, I'm sorry. Alright, we ended up with our lowest point being right here. So our lowest point was 1, 2, 3, 4 up from the origin. So 1, 2, 3, 4 up. And then we had a point here that was 1 over and 5 up. So 1, 5. And then we had a point at -1, +5. So -1, +5. And we know it's going to be that U-shaped curve. So this would, over here, would be the graph of our transformed function. All right, so transformations of functions can be kind of hard to wrap your head around. It's a lot of trying to look at something and be able to picture it. So let me know if you have any questions as you're trying to work through some of this, and you guys have a great day.